Hello, everyone. Come on in. Sorry about the delay. It's taking a long time to get my internet to connect. Hello, everyone. Thank you for coming. See you coming in now. Again, I apologize for the delay. I've been having a hard time even discovering where my Canvas course was. Seems like I've got some corruption in that Eastern Shore has made some courses in my Canvas that I don't know how they did because I don't work there. And it makes it hard for me to find my other stuff too. And I thought it was one of those. I couldn't find it. So, anyways, I literally just got the Canvas course posted. Actually, I got it posted last night, but I couldn't put anything in it until probably about 30 minutes ago. And that's when I sent you the connections. I see y'all got them, so that's awesome. Looks like we got 10 of you in here already. Anybody have any questions before we get started? Can everybody hear me? Okay, cool. Thank you, ma'am. Good deal. And sometimes my sound will go out and I don't know why. So I ask that and I go, yeah, like evidently you can hear this. So all right, looks like we're got a couple more still coming pretty good. I don't know how many students I'm supposed to have in this class. I thought it was like 15. Let me double check. Yes. Oh, we got 17. So I'm only short a few, and those are probably my fault. The good news is as soon as this is finished, it'll start to be this video will start to be converted to an MPEG format, and then that'll be posted on my YouTube channel. So let me go ahead and give you that. My YouTube channel is www.youtube.com/Billy Younger Physics Solutions. So that's my YouTube channel. And each day that we meet, I will actually record it, unless something technologically screws up, but I'll record it and then I will download it and then post it to that website. So if you go to www.youtube.com/Billy Younger Physics Solutions, you will see the most recent thing that I posted at the very top. And not only that, if you look in the description, there will be on the second line, there will be a string of characters that looks kind of random. It'll say like PHY 241 N02 0108 2024, which I think you can all guess is your class, your section number, and the date. So that's the way you can identify exactly what the file name is of video that I posted, and two, that's also the file name of the notes. So when I make the notes on my GoodNotes, I create a PDF out of them and I post them on my Google Docs page, and you can find them with that name. So that PHY 241 0108 2024 will be the name of the file for today's notes. So you always have access to Google Docs, my Google Docs. You don't have access to them now because of the problems I said, but tonight, your first week's module will be posted, and a bunch of other modules that have stuff that's important. So you'll be able to see all of that, including the access to the Google Docs. My syllabus will be up there as well. Caroline, are you asking me a question, holding something up, or are you just thinking about something? Okay. I thought you were holding something up like you had a question or something. Sorry about that. By the way, today I noticed this is the first time this has ever happened, but I had my students just like you guys right now, where they're up at the top of my screen, and your camera's on, so I can see all you, which is great. I like it because I can learn what you look like, and I can hopefully try to learn your names. But today, when I went and posted the first video on my YouTube channel, it showed that on there as well, and it's never shown that before. So I got to figure out how to get rid of that. In the meantime, if you do not want that posted on my YouTube channel, which is public, but it's literally had like 120 views, so it's not that public. But since it's public, if you want to make sure you don't appear on that, even in your name, you might want to change your username to like your first name and then the first letter of your last name. And then you'd also want to keep your camera off if that continues. Hopefully, I'll be able to get that part off because I do like having the camera on, just like I said, so I can get to know you guys a little bit. If you actually have if you have a reason that you really don't need your name out there, maybe you're in hiding from the mob or something. If that's the case, then you don't have to tell me why. You just need to send me an email and say, hey, I cannot appear on your YouTube channel, period. And I will make sure your name nor face ever appears on there. So just let me know that, and in fact, in general, you need to tell me that even if you just don't want to. It doesn't have to be a reason. If you just don't want to, that's fine too. But you need to let me know so I don't post your face or your name on my YouTube channel. So please let me know. Again, it's not a very fancy YouTube channel. I mean, I got a butt ton of stuff there, but it's just not a whole lot of people like to do it. I think my daughter is probably the #1 viewer, and she says she uses it to go to sleep. So that tells you how awesome it is. All right, my email address, I'm going to type it here so that I don't have to say it out loud because this is going on YouTube, of course. But here's my email address. And when you email me, I need some specific things. I need you to email me according to the following rules. Or I'll say following steps. 1, only email from your TCC account. Now, if it's emergency and you just got to get with me and you can't access that one, I don't mind that. It's just a good probability that I won't see it unless it came from your TCC account. You're going to get this in your writing in a second. 2, include your first and last name. And 3, subject should start with, and here I'm going to put it, and I'm not going to say this out loud either for obvious reasons. Okay, so those are the 3 rules, and if you don't obey those rules, there's a high probability that I'll never see your email, and therefore I'll never reply to it. My goal is to reply to you within 1 business day. So if, for instance, you send me an email as early as 12:01 a.m. Friday, in other words, it just became Friday, it's 12:01 a.m. and you send me an email, but since it's Friday, that means I have to reply to you by Monday at 11:59 p.m. Okay, that's the way my 1 business day works. All the other days are pretty straightforward, but Friday, Saturday, and Sunday all revert back to the Monday, and then I have until 11:59 p.m. I'll post it again. There may be a way that you can access these chats. Maybe someone in the class could tell you. I'm not familiar from your side very well, so I'm a little bit of a newbie, and I might be telling you wrong because it's been so long since I had any kind of training on it. So there's my YouTube address, but I don't know if you can scroll back or if there's a file that pops up somewhere. I know there's a file that pops up at the end of class, so I can always send that to you if you ask. But there it is. One thing I found is really good students do, sometimes you just take a screenshot so you can catch the stuff that they're doing, and then you can crop it down if you want. So that's a quick and dirty way to get the actual notes. So that's another thing. Now, I told you that I should reply to you within 1 day. If I don't reply to you, that's the perfect time for you to contact me via text. So I'm going to give you my personal phone number. And of course, I'm not going to say it out loud for obvious reasons, but my personal phone number, I'm typing into the chat right now. And what this is for is, in the event that you send me an email that you really need a response from and you don't get it back within 1 business day, then you should consider texting me immediately. And texting is probably the best way because I don't answer phone calls of numbers I don't know. If I then discover from our text messaging back and forth that I need to talk to you or something like that, I can either set up a Zoom meeting or I can set up a personal phone call. Either one, that's not a big deal. But the main thing is initially you just want to text me. Also, if you ever have something that's really urgent, like maybe you're coming in for one of your midterm exams and there's a traffic jam and it's held you up and it's going to make you be late, that's a good time to send me a really urgent message. And the best way to send an urgent message is to text me at that number. Again, include your first and last name and what your course section is. So the same subject line that you put on the email, you want that in the text message as well, so I can know exactly who I'm talking to. Any questions on that? All right. I'm sorry for not having everything else ready. I don't know if you've heard, but I had surgery on Wednesday before Christmas. It was pretty major surgery. They had to repair and replace parts of a prosthetic shoulder I had put in about 6 years ago. So I'm just having the time of my life sitting here with no pain or anything. But the main thing is just not very, well, I'm a little scatterbrained. I can't do as much as I need. Today has really killed me just sitting here and lifting my arm enough to just to type. It's all been killing me. So a lot of stuff that I would have had done by now is not done. That being said, I sometimes don't get the syllabus done till the second day too. So that's often the case. So I don't want to blame it all on the surgery, but I just wanted to tell you guys it will be up. Worst case scenario, you won't see it till tomorrow morning, but I hope to have everything posted tonight. When I do post such things, I will send you emails to let you know. So keep an eye on your email. You don't have to. I mean, just if you're anxious to see the stuff, if you're anxious to get started on your first homework assignment, if you're anxious to see the syllabus, then yeah, watch your email and I'll let you know. Okay. We are using Giancolli's 5th edition. So this is and that's super helpful when people call me. Spam, of course. It completely takes away all my buttons on my computer and everything. So this is physics for scientists and engineers. 5th edition, well, I should say, with modern physics. 5th edition by Giancolli. So that's the textbook that we're using. If you want to be the least expensive, if you want to spend the least amount of money on getting a book and everything you need for this course, then first off, I'll tell you, you do need a scientific calculator, and it cannot be one that's on your iPad or on your phone or anything else that can store photographs and well, lots of photographs and lots of pictures of notes or lots of documents, or can access the internet. So any scientific calculator that's on a device like that, it's not going to be able to be used. So you just need to buy you a scientific calculator. And to be honest with you, if you're majoring in science or engineering, you need a scientific calculator. This might not be the best time to buy the best thing they have, but it's still a good time to buy one because you really have to have it. But you'll need a scientific calculator. You'll need something to write with. Most students use pencil. Technically in lab, you're always supposed to use pen and not erasable pen, just for the record. That being said, I don't take off from my students if they don't use pen or something like that. I'll just tell you that the rule is you write in pen, and if you make a mistake, you draw a single crisp line through the mistake so that anybody can read exactly what the mistaken thing you wrote down was, and then you write the correct number next to it or the correct thing next to it. You also need a protractor and a ruler, a centimeter scale ruler and a protractor. I would advise you to have at least 10 sheets of graph paper, but I do not require that. So those things you need. Now, again, if you want the cheapest version of the textbook or what you need for the course, in addition to those things I just mentioned, the best way you can do this is once I have week module 1 up, there'll be a link to chapter 1 homework there, and you can click right on it. It'll say chapter 01 HW. And at that time, they'll ask you for an access key or access password or something like that. If you've already bought the book and you bought it appropriately, like you bought a new book from our student store, or you bought from another book vendor who maybe shrink wrapped a book that was used and put the access key in it, that's fine too. If you did that, then you can go ahead and put in the access key and you'll have everything. But that's not necessarily the cheapest way. The cheapest way would be go right to that site and purchase it there. For starters, you get like, I think it's 2 weeks free. So starting today or yesterday, you get 2 weeks free. So there's no reason for you to do your homework late. You are going to lose points if you turn it in late. But what you want to do is go there, purchase that, or at least do the 2 week free trial. And then at the end of 2 weeks, you can make the purchase. But what you'll do is you'll purchase something, assuming you take 2 semesters, you want something, a license access code that lasts long enough to get through 2 semesters. And that includes the ebook. If you do it that way, then you'll automatically have the 5th edition of the textbook in electronic format, and you'll have full access to the MyLab and Mastering, which is where all our homework assignments will be. But you'll still access them through Canvas. So we only have one course or one website you have to go through, and it's all Canvas. So that would be the absolute cheapest way. If, however, you're one of those people that don't like just reading in an electronic format, there's a cheap way you can go beyond that. You can still buy that ebook version, and then you can look on eBay or Amazon or anywhere else, look for a used copy of either the 4th or even the 3rd edition of the same textbook. So the same title would be Physics for Scientists and Engineers with Modern Physics. And you could buy the 4th or the 3rd edition of Giancolli's textbook, and that would be plenty, because the actual text, the part that you read to try to learn how to solve problems, is not hugely different. Some of the examples are different. Some of the examples have been changed. Some of the examples have been corrected, that kind of thing. But to be honest with you, you get plenty out of that. And since you have the ebook, if I ever assign a problem set or a test or something out of the textbook, you have access to the 5th edition ebook, so you can still do that. Everybody understand what I'm saying there? So now, the next cheapest way you could do it, if you wanted to, is you can get a binder ready version, and some booksellers will sell you a used version of the binder ready where they shrink wrap it with the access code. And that is probably, I doubt that's going to be as cheap as buying it online with the ebook, but it'll be pretty close. Okay. And you get a physical book that way. So that's another way of doing it. Anybody have any questions on that? You don't see it right now on my Canvas, but you will go to it. Someone asked, what website can we purchase directly from with the ebook? Over here on the left-hand side of Canvas, let me share my screen real quick. So right here on the left-hand side of Canvas, you see these links. Well, they're not all there right now. And not only that, someone changed one of them over the break, and it's really confusing. So I'm going to show you what it is, because it's the stupidest thing I've ever seen in my life. I'm sure they've got some reason for it, and if I knew it, I wouldn't be able to call it stupid. But I like being able to pretend that something's stupid. My ignorance makes me happy sometimes. So notice this is all the stuff I can actually put on there. But what I'm going to put is, let's see, this weird little thing right here. So this used to say MyLab and Mastering. It doesn't say that anymore. It now says Pearson at Nova dash. So I just hit save. I don't see it, but if oh, Infinity P maybe. Gotcha. She's a public place to see. No, it wasn't her. Sorry, Infinity. And then that noise is gone now. Okay, so if you see now, I'm going to go back to just modules, for instance. So right here, Pearson at Nova-DE, it won't do you any good to look right now, so don't bother. But that's one place where you can go straight to the website. The other place is right down here. There will be several modules. Each of these things are called modules. That's a module. That's a module. There will be a module that's got a bunch of random links that are helpful for the course. There's a module for practice tests. There's a module for chapter practice. There's a module for online tests, for face-to-face tests. And then there will be a module for week 1, January 8th to January 11:59 p.m. on January 14th. In that module, you'll see chapter 1 homework and chapter 1 conceptual. You can click on chapter 1 homework or chapter 1 conceptual, and that'll take you to the website that you can purchase the information from, or purchase the book and all that stuff from. Everybody get that? I think it was Caroline that asked it. Yes, it was. Okay. So it's going to be there. When I post this stuff, since I had these problems, I will send you an email. So you're going to get a lot of emails for the next 24 hours just from me. And they're me letting you know what's been posted. In case you're interested, I want to support your enthusiasm as much as I can. So I'm going to try to let you know when anything comes out. The rest of the semester, I won't be sending you emails that rapidly. So don't worry too much about it. But as I said, if you want to go online and try to purchase the access code with the ebook, you can either do it here when that's ready, or you can click on chapter 1 homework or chapter 1 conceptual. Later in the semester, you can even click on chapter 2 homework, and so on and so forth. Any questions on that? Okay, I'm going to also, I'm doing some crazy stuff here. I'm going to open up a second version of Canvas, which is really, my internet telling me, our Zoom is telling me my internet connection is unstable, so I could lose all of you at any instant. Hopefully we won't, but that's a possibility. The good news is I've recorded enough of these lectures. If we miss something, you have a ton of them in the week 1 that you can replace this with. So what I'm going to do is I'm going to open up the dashboard where my courses are. And in that dashboard, I'm going to go to another course that's already set up and ready to roll, which I think is this guy right here. And that's going to, oh, I did the wrong one. I want that one. Great, that'll take a lot longer. So I'm going to open up another PHY 241 class and then open up the textbook in there, so that you can see what we're talking about and and all that good stuff. Anybody have any questions before I proceed? All right, looks like it's opening up now. I am on 241. Are y'all seeing 241 D01B at the top left here? You can speak out loud or give me a thumbs up or chat it. Does everybody see PHY 241 D01B? Does anybody not see it? Let's go that way.
Yes.
Okay, cool. You just see it. I just making sure. Sometimes when I flip tabs, I'm not comfortable with whether or not Zoom knows it. So now I'm going to click over here to do the Pearson Nova DE. Oh, I should have done so. I'll do that in a second. So when I clicked on Pearson Nova DE, again, that used to be the MyLab and Mastering link. It'll pull up the page to get me to MyLab and Mastering. You see Open MyLab and Mastering. This is where you can access your grade book, you can access individual assignments, so on and so forth. What I'm going to go to is the ebook. So now you see the black screen. I'm waiting for it to load, and this is a nightmare. It does one link and then opens up another tab and then does another link and then opens up another tab. It's just a nightmare. So I'll see what we can do. All right, got another student coming in, get more of them. But I definitely hear a little kid talking. If someone could mute that, that would be awesome. I don't generally mind little kids. I love kids, in fact. But I like to make jokes like I don't like them. I like to call them morons or play, Sim City with them getting hit by balls and stuff like that. So that's just me being goofy. So ignore me if it bothers you, or if it does bother you, just email me and I'll do my best to stop. All right, so I'm coming up to Pearson. It's taking a really long time, which makes me feel really great. While I'm waiting for that, I'm going to go back to here. That's the same course. I don't want that. So what I'll show you now is I'll click on modules. This is the 241 face-to-face class, and it's going to be set up just like your class. So what I wanted to show you is you will have this, which is the generic stuff that TCC requires me to give you access to. So the TCC student information support. You'll have this, which you only have one because you guys are not in my lab. So I don't necessarily, well, you might be off the record on my lab. That's okay, but you won't need a link to that. The link to that will be in the other class. If you are wanting to do my day lab, if I can accommodate you size wise, then you can do that, but I'll have to put a link up here for it. Interesting science related links and documents. That's all there. These are just good resources. Some of them are just books, like for instance, American Prometheus was largely the book that Oppenheimer was recently based on. I read it a few years ago. It's really a great book. Helpful documents and links. This is where your syllabus will be, but is not yet there. Okay. And of course, I'm looking at a different class anyway, so that wouldn't help you. But this is where your syllabus will be. You'll see that this will be where your link to my YouTube channel is. And you will also see this is where my link to my Google Docs is. So this is where you can click on to download notes from a given class day. So you'll see that there. You'll see chapter practice. I have these things, practice tests, and they are really practice tests that are geared for the upcoming test. And normally the face-to-face tests are 2 chapters, whereas like a midterm might be 4 or 5 chapters because it's comprehensive, and a final will be like 12 chapters. Those will test all those chapters, and therefore they take a little bit of time. If you find that you've got a weakness in chapter 3, for instance, the best thing to do would just be go to chapter practice and do these, because these guys are like 3 or 4 problems each. I never see the score, and you can do them over and over again, and it's a lot quicker than the practice tests. But really, when it comes time to prepare for the test, you should try to do these practice tests as often as you can. I won't make these available today, but they will be probably the next couple of days. But you can see how they're laid out. And these usually have like 8 to 6 or 10 questions, and they take a little longer. But the main thing is I give you copious amounts of extra credit for doing them. And not only that, I shouldn't give them to you, but I've learned that if I don't give you extra credit, you won't do them. But here's the funny thing. When I actually make the test, I use the exact same bank of questions that I made for the practice test. I use that same bank for the test. So in principle, if you took the practice test enough times, you would see every possible question that could ever come up on my tests. Now, I guarantee it's going to be at least, I usually say 80 to 90%, but to be honest with you, it's been 100% for about 4 years. So what I do at the end of the semester, and yeah, I said do. What I do at the end of the semester is I take your highest score on each of these practice tests and I average them all together. And then I divide that number by 20, and that number of points is added to your final course grade. So if, for instance, if you had done each one of them, didn't skip any of them, and you got at least 100 on each one of them, then your practice test average would be a 100. If you divide that by 20, you get 5. So you could literally get 5 points. That's half a letter grade added to your course grade just by doing those. So 1, you'd be crazy not to do it just because I told you I'm using the same bank. And 2, you'd be crazy not to do it because you get a bunch of points. Okay. That being said, completely optional. There will be a link down here for online tests. There will be a link for face-to-face tests. That's where you'll find them when you go to take them. These 3 might not appear for a couple of days. That's okay. What will appear tonight or by first thing in the morning is this week 1, January 8th to 11:59 on January 14th. These are all videos of past lectures or past problems I solved related to this first chapter. So all of these are links to my YouTube channel, and it will actually give you parts that we covered. Like these are just short little clips, but some of these are full-scale lectures. So they're like, in the case for my summer classes, they're like 3 hours. You don't want to do that, but you can skim through them and see where the problem solved are. It also has a document to teach you how to do sig fig rules. There's a video on teaching you why sig fig rules are crap. There's a document on teaching you how to read vernier calipers. That's actually a video, sorry. This is the lab. You guys will not have this whole lab part in here, but I probably will make some of this stuff available just so it'll help you in your own lab. Then you'll have an extra credit section. So whenever I make extra credit assignments, you would actually see it there, see its due date, and you'd submit it as a PDF there. So I just wanted to show you that so you know what it looks like. You can see it's going to go on for the whole semester, and you'll have a bunch of videos that will, you know, be a resource that you can use in the event that you didn't understand something I said. Maybe I'll explain it better there. You can just pull it up and go to the part of the video that you are interested in. If some of the videos are old, and it was when I did it with a camera and basically a clipboard, pen and paper. So some of that video wasn't that clear, and it was not that easy to read the documents. But that's why I have up here the Google Docs, because as I said, when you go to my lab, or when you go to my YouTube channel, you'll see that each video has in the description a weird looking name. So let me show you that real quick. This is still not done. Let me open up another one. See if we can take about a week to do that. Y'all should be seeing a black screen. Now you should see my Chihuahua smoking a cigarette. Everybody see my Chihuahua smoking a cigarette? He's my cute little buddy, so I use a lot of things. I use a lot of Photoshop to mess with him a little bit. What I'm going to show you here is I'll just click on the last one I posted. And this is a whole lecture. So you can see it's an hour and 29 minutes. Not a lot of people want to watch the whole hour and 29, but you can, of course, fast forward and find the problems that you're interested in. But what I wanted to show you is down here in the description, see this PHY242N01B space 11/28/2023. So you can do a search just for that in your Google Docs. Well, in this case, it's not going to pop up because that's a 242 class and yours is a 241. But you can do a Google search for just that particular date, and it'll pull up the very document with the name of this whole thing right here. That will be the name of the file, and that's a PDF of the notes that I've made on that day. So even if you get to a part of the video that looks kind of crappy and you can't read the notes, you can still download them in PDF form. Of course, it's just like a normal YouTube channel. You can do searches. Like if you want to know something about sig figs, you can type, make sure you type here, not up there, but you can type right here, just sig, like sig fig, and it'll give you a video that's related to sig figs and when they fail. So this is me explaining how significant figures are not that good. Here's me explaining the more robust way of doing it. You can see that's a whole hour and 32 minutes, whereas that one's only 16 minutes and 30 seconds. Here's me solving a problem where a police officer is chasing a speeder. Here's measurement and uncertainty, which is sort of the beginning of the error propagation stuff. So all that's available. You can see there's just a ton of videos in here. Some are short, some are long. You just want to look for, you can just sort of flip through all of them and look for a title that looks familiar, or you can do a search whenever you need to. And if you're really looking for some help and you still can't find it, send me a text message and ask me, hey, I'm trying to figure out something like this problem. What video or what search parameters would you want me to use in your YouTube channel? So I can help you that way too. All right, so I'm going to kill that. Now I've got the book open. You can see I'm still uploading the last video, or actually the first video I did this morning. I thought it would be done by now. I set that up at 3:30 and it's still not finished. So that's a problem. Oh, good. The textbook's not loading yet either. That's really super. This is great. Okay, so what I'm going to do is punt a little bit. Okay, I had these things that I wanted to show you, but the internet's going too slow. But I have my iPad, and I'm going to use it and share my screen with you to go over chapter 1. So chapter 1 is called oops, hold on, I was muted. Can anyone hear my voice?
Yes.
Okay, cool. Thank you. Sorry about that. I don't know what's going on, but the instability of my internet connection must have finally kicked us off for a split second. All right, I'm back. And it looks like hopefully everybody's still here. It looks like everybody is. All right, so what I'm going to do is I'm going to do a share screen. And I'll do that. And I would do this. I've got to do a little prep work while I'm doing this. I'm going to share. Do this here. And now while this is loading, I'm going to attempt to set this up correctly. So now I got the file labeled appropriately. And you guys should be seeing this. Notice it does have my URL for the YouTube channel up at the top. So the first thing the chapter wants to talk about is science and how science progresses. I will tell you that when you take the practice test, when you do the homeworks, and when you take the actual test, any questions that appear in there about scientific method and that sort of stuff is going to come from what Giancoli told you in the textbook. I'm giving you a little different perspective because I pay attention to the skeptic movement. I don't know if you're familiar with magazines like Skepticality or podcasts like The Skeptic's Guide to the Universe or Skeptoid or any of those type things. I've been following that for a few decades because I think it's a real danger what a lot of pseudoscience is trying to be thrust upon people. And it's really a serious danger. So I pay some attention to that. To be honest with you, the science of physics is not usually laden with many pseudoscientists because it's really such a science that it's kind of hard to fake that. However, there is a little overlap with, for instance, global warming and physics. So there's some pseudoscience that comes in when discussions of global warming. So it is somewhat relevant, but Giancoli just hasn't found it that important. So he hasn't addressed the scientific method with an eye on that particular issue. Some textbook authors have. For instance, there's an author that wrote a physics 100, which is conceptual physics textbook, that did take that role, and he talked about pseudoscience and that sort of stuff. If you're interested in that, I can give you a link to Hobson is his name. Hobson, Hobson, is the author's name. And I can give you a link to his book or whatever if you're interested in it. They probably have a copy of it that the library can get if you want to read it. But the main thing is I just want to tell you that the author here has a very distinct discussion of the scientific method and that sort of stuff. And it differs a little bit about what I'm saying. So when it comes down to you answering questions on a practice test, on a homework, or on an actual test, since I'm using the bank from Giancoli, you want to think more about what they're doing. So let me give you an idea. To me, science is a cyclic process. And that's just supposed to be a V there. Observation / experiment. And I put observation there because sometimes your initial intro to an area of interest really is just something you saw and it wasn't in a controlled environment where you could do an actual experiment. But also the oldest science is in fact the science of astronomy, and they specifically have a lot of experiments they can't do. They can't, for instance, make a star. They can't make a moon. They can sort of make a satellite. I mean, obviously we can make satellites. We can't make solar systems. We can't make galaxies, that sort of thing. So some of the experiments just have to be in the terms of observations where you look at what it's offering you. So what I say is often the scientific process starts with an observation or an experiment. And then from that observation or experiment, you form a hypothesis. And a hypothesis is better than a guess, but not too terribly much better than a guess. It's a guess based on solid information. So, for instance, it's the kind of guess you would make after you've actually seen something happen. Like I could look out in my front yard and I see a toddler, and they're like uncoordinated goobers. So they go to throw a ball and they stiff arm it and they just sort of like that. And if you look at the ball, it sort of falls falls out of the person's hand and then lands on the ground, and it looks sort of like an arc. You might make a hypothesis, and this sounds like a really stupid hypothesis, but to be honest with you, this is a way a lot of science is done. You might make the hypothesis that, oh, it appears that balls, when thrown, trace out parts of circles. That's a hypothesis. And what makes it a scientific hypothesis is that I can falsify it. I can do an experiment that definitively tells me I am wrong. And because it definitively allows me to determine that I am wrong, then it's a scientific hypothesis. You do not have to have a test that can prove it right. You do have to have a test that can prove it wrong. It's not that tests that it's not that hypotheses that can't be disproven or can't be falsified. It's not that they're not valuable. It's just that they're not science. So they're not that helpful in the science realm. So I could go, for instance, and say, okay, well, yeah, I believe that thrown balls follow the path that are consistent with a part of a circle. And I would maybe soup it up a little bit and say, and the radius of the circle is equal to the distance from the ground up to the bottom of the ball upon release from the person's hand. And then I could go and watch a bunch of kids do that, and I would maybe even film it and then plot the points in some software like we use in our labs, and I could find out whether or not that is actually a circle. And for a while, I probably find that it's pretty close to being right, especially when I'm dealing with toddlers. But then I go and watch a professional baseball game, or even some softball players around town, high school girls, high school boy baseball, any of that kind of stuff. And you'll see a lot different trajectories. And I slowly would have to dismantle that hypothesis. But as long as that hypothesis keeps giving me correct answers, I can keep doing the process where I make a hypothesis, and then from the hypothesis, I make a prediction. And that prediction has to be falsifiable. And again, it has to be falsifiable if I'm using science to analyze it. So if it's to be addressed by science. Again, I want to tell you that a non-falsifiable hypothesis is not definitively bad. It's just not applicable in the sciences. Okay. Now, from that prediction, which again, I have to have some test to show that it's wrong. And for instance, any deviation from a circular path would be a falsification of my hypothesis and my prediction. So that is definitely a falsifiable hypothesis. And then the next step is I go back and do another observation or experiment. And I keep doing this process over and over and over again, going around and around and around. And as long as that hypothesis is never is never falsified, then things are going good, and the hypothesis is just getting stronger and stronger. I can soup it up more. I can start to take into account how fast they throw it, what's the acceleration of gravity, all sorts of stuff like that. And if I'm still keeping with that same hypothesis, just adding bells and whistles, I'm just building a whole paradigm of thought. And if I keep going through this cycle over and over again, say on the order of millions of times, then if I've never once been proven wrong, then it becomes a theory. Okay, notice that's a different wording than you're used to. And in fact, it's a wording that I've violated and many other scientists have violated many, many times. But specifically because of this inundation of pseudoscience across the board, from people using pseudomedicine to try to treat really curable illnesses that result in some cases literally the death of a child, and then the parents still won't back down. So these things are kind of important. It's important to know. So when we do this hypothesis, and then we make a prediction, and then we observe that it's not falsified, and then we make another one and keep doing that, it eventually comes to the point where we can call this whole region of thought or paradigm a theory. And as long as it's never been proven false, then that theory is a theory. The theory of gravity, according to Newton, is such a theory, but when Einstein came along, he showed somewhere where it was leaking or where it had a problem. And in that sense, we could, in principle, have to throw away Newton's law of gravity. But luckily, Newton's law of gravity is simple. Einstein's theory of relativity, general relativity especially, is particularly complicated. And there's so many areas of physics where Newton's gravity works that we didn't throw away Newton's gravity, we just keep it, but we know that it has limitations on its functionalness. So if we're dealing with extremely huge gravitational forces like ones with black holes or galaxies or something like that, or if we're dealing with speeds close to the speed of light, then we know we can't use Newton's laws of physics or Newton's laws of gravity. We actually have to use special and general relativity. So it's still Newton's theory of gravity and is respected. We could, for instance, plan a trip to the moon. We could plan a trip to Mars. All of that we can do with Newton's law of gravity. And other than our timepieces being a little bit off, we totally get the right answers. Okay. So that's how this process goes. And it's only, like I said, once you've been tested millions of times or even more. For instance, special relativity has probably been tested over 100 million times. We think it's the single most tested theory in the history of mankind. So it's very unlikely that we're ever going to find special relativity to be wrong, but it still could be. And like Einstein said, it only takes one experiment to show me wrong, and there's no number of experiments that will ever prove me right. I don't care if you get 700 billion experiments showing my hypothesis right. If one experiment comes by later and shows it wrong, I sort of have to throw the whole thing away. Now, I'd want to check and make sure that experiment was well done. So I would ideally like to see another experimental group do the same experiment. And if they found the same result, then I'd start to say, okay, this is looking bad. And if a third came out, I'd say, oh, it looks like I'm going to have to wrap it up and throw it away. Okay, that's what happens. So that's my idea of telling you how the scientific process works. And in this case, I started off with observation. That's not always how it happens. For instance, Einstein introduces special theory of relativity, not from observations, but from thought experiments. He basically looked at Maxwell's equations and saw that you got a lot of paradoxes if you imagine riding on a light beam. And the only way, for starters, if you have a paradox, that's a fundamental idea that says, hey, something's wrong with your science if you've got a paradox. So whenever we find paradoxes, we know either the paradox is not a paradox, or two, the science is jacked up. So in order for him to get rid of the paradox, the only thing he could come up with is making the hypothesis that the speed of light is a constant independent of the motion of the source or the motion of the observer. And in doing so, he managed to find the special theory of relativity. He found time dilation, length contraction. He found E equals mc squared, which explained how our sun had lived so long. He had the E equals mc squared that allowed us to figure out how the nucleus worked and therefore make us nuclear weapons and nuclear power plants. So it was really a big deal. That's not, by the way, what he got the Nobel Prize for. He got the Nobel Prize for his work in quantum mechanics on the photoelectric effect. But still, the point is, you don't have to start with an observation. You can start with a hypothesis like he did, or a prediction. The main thing is you just start and then you go through this cyclic process over and over and over again. Now, we only got about, actually, I think we're supposed to go to 6:40, so we got more time than I thought. So that's my blurb on the scientific method. Your book will talk about hypotheses, theories, and laws. And there's a bunch of different ways to interpret the word law. For instance, we have the scuba diver's law. Anybody a scuba diver in here or ever taken a scuba diving class? So it's something called Boyle's law. Is the sort of the never hold your breath, never hold your breath, never hold your breath. That's the fundamental rule, but that all comes from Boyle's law, which says that pressure and volume are inversely related. That was historically named the law. and therefore we call it a law. That's one way you might make something a law. But also, if you actually do a series of experiments, you find out that in a closed volume of a gas, if you increase the pressure on the gas, the volume will decrease. Since it's stating an actual fact that we see over and over again, there's another reason for calling it a law. Okay, so you can see there's a bunch of different reasons to call something a law. Your book talks about that. Theory, like I said, is supposed to be a strong word. No one should ever put the diminutive just in front of the word theory. So you shouldn't hear someone say it's just a theory unless they're one, trying to pull the wool over your eyes, or two, they're ignorant of science. And I say ignorant, not stupid. Very smart people are ignorant. I'm ignorant of a lot of things. I don't know how numerous things work. So in that sense, I'm ignorant. And I've had people tell me that, and I have to say, yeah, you're right. So it's okay. I'm not going to call any of you that, okay? But I would on Facebook, because I'm a beast on there. But anyways, ignorance is not supposed to be an insult on your intellect. It's more a question of your experiences. Okay, so just keep that in mind. Maybe that'll go over a little smoother in future discussions. But that's enough for right now in the scientific process. So make sure you read chapter 1. It is really important for you to try to slowly transition yourself into learning how to read a science book. That is not something that's trivial. A lot of people just can't take a book or a white paper and read it and then apply that immediately. But as a college educated person, that's one of our goals, is to teach you to be able to read so well that you can read something. Maybe you have to read it slow, maybe you have to read it a couple times, but then you can actually apply it to do something. My wife told me, I didn't really think that much of it, but my wife one time said, you're really gifted in that. And I think she was talking about something I'd done. I'll just say one case where I know someone said something about, I read a book on electricity and wiring, and then I wired a building. So I balanced the circuit breaker panel and all that kind of stuff. That seemed fairly trivial to me, not because I'm brilliant, but because I've taken a lot of time to try to learn how to read. It's taken me a buttload of work to do so. So that is something that we would all like every one of our students to be able to do. If you don't, that's okay, but keep getting better at it. The better you get at it, the better you'll be, and the more an employer wants you, because a lot of times that's actually how things come down in the private sector is, hey, someone writes a white paper and then you have to figure out how to apply it. For instance, I used to do structural engineering at the beach, and the ASDE 798, which is a publication by the American Society of Civil Engineers, they actually worked out the details of how to do wind analysis on houses for hurricanes and stuff like that. And it's literally just like a 6-page paper. And I've met numerous engineers who didn't know how to do wind analysis, even though they were working on the Outer Banks, where obviously wind analysis would be an important thing. And then I just went in. I didn't have the software that would do it automatically for you. I just read the document and worked it out, made a spreadsheet, and you can do that. So that actually more or less got me a job as a structural engineer, where I had just been doing stuff like surveying and wastewater engineering. But when they saw I could do that, then they moved me into the structures department. So that was kind of cool. So it's just a goal to look for, and I can teach you some of the things that are necessary to do it. And all you have to do is ask. I'm not going to try to talk about it too much. Every now and then I'll get on the soapbox, but generally I don't. Now, the other thing that or the next thing that I want to discuss is the systems of units. So there's a lot of units that work. For instance, there's a system of units that a lot of people call the British system of units. And oddly enough, I think America is the one major nation that uses the British system of units. No other major nation does. And I want to say it's Liberia is the other country that still uses it. It might not be Liberia, but Liberia is one of those ones that we've sort of taken under our wing and tried to help out for some time. So they might be the one, and that's what's coming to mind right now. But there's literally 2 countries that use the British system, us and that other country. So it's not a very good system. It's what we call a historical system, and it has really crazy stuff. Let me see if anybody recognizes this. Let's see.
Are you doing like the quart, so many gallons in a quart, so many?
Has anybody ever seen anything like this before? It gets worse too. Each of these P's is supposed to have 2 C's in it. And each of these C's is supposed to have 8 O's in it. And that's about it. But you can see that. Anybody recognize what that is? Especially if you've been in public education at elementary school level, you've probably heard it. I call it the G-man, but it's basically a mnemonic that we use to try to remember how to relate gallons to quarts, gallons to pints, gallons to cups, gallons to ounces. And if you, for instance, have to mix gas and oil to run your weed eater or your leaf blower or your chainsaw, yeah, you got to use that, because ultimately they're going to sell you oil that's measured in ounces, and you're going to buy gas that's measured in gallons, and you need to have a ratio of 50 to 1 or 40 to 1. And in order to have a ratio of 40 to 1 or 50 to 1, you have to have the 40 and the 50, or excuse me, the 40 and the 1 or the 50 and the 1 in the same units. And you can't do that without the G-man. And it's a nightmare, right? It's a non-rational set of units. And in fact, part of what created America is in fact the Enlightenment. And people like John Locke and Francis Bacon and Thomas Jefferson and these folks were very big Enlightenment characters. And I don't know if you realize this, hopefully you do, but when Thomas Jefferson made the Louisiana Purchase, he purchased that from Napoleon. So that gets you to realize that Napoleon and Thomas Jefferson were about alive at about the same time. And that also tells you that the Enlightenment was a time in which Napoleon was ruling France. And in fact, that's why we use here nowadays, we use the SI system. So SI equals system. And I don't know French, so I'm going to put some random letters in here and make it look Frenchy. And I'm almost completely sure that I'll be 100% wrong. So I'm going to call it Système International. And I'm going to laugh at myself later when I actually look this up. So yeah, that's what the Système International or something. I don't know. Like I said, I've never taken French. I don't know. I don't know English that well either. So that's the system of units we use, and it's in French. And you think, why is it in French? Well, guess what? It was started under Napoleon. So we started to make our system of units rational at the same time Thomas Jefferson was in office. But guess what? The superpower at the time was France. And therefore, France got to name it, and we got the Système International. We call it the international system, but it's also called the metric system. And it's also called the MKS system, where M is meters, K is kilograms, and S is seconds. Now notice the K is kilograms, which has a prefix. So there's this weird thing in that we treat the Système International, the SI system, as if it's a base unit with prefixes. And then we tell you the base unit for mass is the kilogram, which has a prefix. So in reality, the way I like to tell people is the base unit is the gram. But if you're ever going to use an equation for that's designed for use in the metric system, then you have to use the kilogram as the mass unit. Okay, so when we use Newton's second law, which is probably one of the 2 physics equations you already know, no matter how much physics you've had in the past. Anybody know Newton's second law? F equals ma, right? So if you have an m in an equation, that means you better put that m in kilograms. Okay, so that's the Système International, and it's a rational system of units. In other words, it doesn't allow history to make up the units we have. It allows good sense and good stewardship with numbers to do it. This is the British system, or the imperial system. Of units. And as I said, we call it the British system, but Britain doesn't use it anymore either. Okay. So let me give you an intro to that. I'm going to give you a mnemonic, and I'm also going to warn you guys that I am forever a young boy, somewhere from 4th grade to 6th grade. So all my jokes are about, poop and pee and butts or something goofy like that. Okay. So I'm really immature that way. So a lot of my mnemonics end up, going down the rabbit hole to something that's stupid and childish. So I apologize in advance when I do that. I'm not trying to be offensive. It's just I've been struck in that, and I'm 53 now, so I really shouldn't be. But anyways, so the mnemonic that started off so well because my wife Shawnee Bear gave it to me was this one. It was the ... These dots are important now. Great ... monarch ... King Henry died by for base, drinking chocolate milk ... under. Notice that's not really a U, that's a mu. That's the Greek letter mu. You can type a lowercase m in Word, highlight it, and change the font to symbol, and that's what it'll be. So under, and this N is where I'd say numerous, and then the next word goes right off the rails, so I'm not going to bother giving it to you. Please come up with your own mnemonic that doesn't involve something that a 5th grade boy would say. Okay. But this system works really well. What it is this is the base unit. And the base, for instance, in terms of MKS, would be the meter, or the gram, or the second. But there's also units like the hertz, or units such as Kelvin, or units such as degrees Celsius, or moles, or candela, or lumens, all sorts of stuff. Liters is another one. Our lumen is another one. So those are all bases. And then what you do to make it rational is, what if I need a much bigger quantity than a gram? Well, I can put a prefix on it that represents a bigger amount of the base. And what differentiates one symbol from the next, whether it be a DA, a H, a K, or one of these dots, is powers of 10. So for instance, if I did a DAM, that's a decameter, that would be 10 meters, because I've multiplied the base by deca, and deca represents 10. If I did a HM, that would be a hectometer, and that would be 100 meters, because I've multiplied the meter by 10 to the 2. So we can put this up here and say, oh, that's 10 to the 1, that's 10 to the 2, that's 10 to the 3, which is probably the one you already knew. I bet you all knew that a kilo means 1,000. And remember, when you raise a 10 to a power, that power is just the number of zeros that the number will have if you write it out. So 10 to the 3rd means 1 followed by 3 zeros. 10 to the 2 means 1 followed by 2 zeros. But notice you go 10 to the 4th for the first dot, 10 to the 5th, and then this guy becomes 10 to the 6th. So Megamind, for instance, if y'all recall that movie, Megamind evidently has 1,000,000 minds, at least on this system. Okay. And then Giga would be 10 to the 9. So if you went to go gig frogs, you might catch a giga frog, in which case you call it 1,000,000,000 frogs. And yeah, I'm doing some cheesy stuff here. Okay. And then this last one is Terra. And I can't remember if it's TERRA or just TERA, but that's 10 to the 12th. Now, what if the unit of the gram, for instance, was too small, or excuse me, was too big? I want to measure, the mass of the wing I just pulled off a fly that I caught stealing my French fry or trying to eat part of my French fry. If that's the case, then a gram's just not going to do it. So I could go to 1/10 of a gram, which is 10 to the -1, and that'd be a decigram, which, by the way, is also a sonogram. Okay. If you've ever had any experience, maybe with yourself having a baby, or your mother, or your sister, or your aunt, or something like that, when they actually measure, cervical dilation and stuff like that, they use something called a sonometer, and a sonometer is just another word for a decimeter. It's basically 1/10 of a meter. Okay. Excuse me, 100th of a meter. So it's 10 to the -2, which is a centimeter, and then 10 to the -3, which is the millimeter, 10 to the -6, 10 to the -9, and 10 to the -12. So this mnemonic gives you the orders, but it also gives you a way to convert units. So for instance, if I had 0.000 0.00000000123. Let's say we had this many gigahertz. Convert to, let's say, nanohertz. So this is not the way I recommend a calculus-based physics student to do it, but in a pinch, it'll work. And this is definitely the way I'd recommend a lot of biology majors to do it, or people in medicine. They don't have to do that often, and I will warn you that the science of medicine and the science of biology in general is getting a lot more mathematical. I've, for instance, been studying a little bit of neurology lately and neuroscience, and yeah, they're actually writing computer code and all sorts of crazy stuff. So those sciences are getting more mathematical. But let's do this. So I will show you how to do it with this system. And what you need to pay attention to is that I am counting my moves. I'm not counting the endpoints, I'm counting the moves. So what I have currently is the gigahertz. So I'm currently right there. So what I want to do is see how many moves I have to make to get to the nano, and in which direction I go. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I had to do it really fast like that because this open notes will make it some fancy shape if I stop for even a second. Notice I did keep count. And what I learned is I had to make 18 moves. Notice I counted all the dots and I counted the base too. Okay. And I had to move it to the right. So that means I have to move this 18 places to the right. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, like that. So it turns out that this is 1, 2, 3, 4, 5, 6, 7, 8, 9 nanohertz. So notice by writing it that way and counting the moves, I'll say this here, count the moves, not the endpoints. By counting the number of moves in which direction, I knew exactly the number of moves and in which direction to move the decimal place, and that gave me the right answer. I could also do something like, let's say, convert 1, 2, 3, 4, 0, 0, 0, 0, 0, 0 micro liters to, let's say, let's convert that to megaliters. So micro, remember, is right here. So I'm going to count my moves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 places to the left. That means I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to say 0.001 234,000,000 megaliters. And obviously we don't know, we had assumed since they were written to the right that they would actually be sig figs. We don't really know that though. So basically we could end that after the 4, and you'd say 0.001234 is the number of megaliters. Any questions on that? So this thing gives you that ability, but again, maybe while you're getting your training wheels off, you use this method to convert back and forth between certain prefixes within the SI system. But we're going to learn a more robust way of converting units when one might be in the SI system and the other might be in the British system and stuff like that. That method also is helped by this, because by writing it that way, you can write the 10 to the 1, the 10 to the 2, the 10 to the 3, the 10 to the -6, so you know exactly what those units mean. So you can ultimately, for instance, look at that diagram up there, and from that diagram, you conclude that 1 meter is equal to, let's say, 1,000 millimeters, or you can say that that's supposed to be 1,000. 1,000 meters is equal to 1 kilometer. So the way we're ultimately going to convert units is we're going to make up true statements like this, what we call facts, where the left side is equal to the right side. And then we're going to use this thing that we learned in math, that basically if you ever multiply a number by 1, then you haven't changed the number at all. Then you just need to know that 1 has a lot of different forms. 1 can be 1, it can be 1.000, it can also be 1 foot equals 12 inches, because really all that makes it 1 is that the numerator is equal to the denominator. It could also equal to 1 over 1. It can also equal to pi over pi. It can equal 1,000 meters over 1 kilometer, but it can also equal 1 kilometer over 1,000 meters. So what you do is you make a 1 that's helpful, a 1 that allows it to cancel out the unit you have and bring you closer to the unit you want. So if I had, for instance, a certain number of kilometers and I wanted to convert 5 kilometers to meters, then I would want to use that 1,000 meters over 1 kilometer, because when I multiply 1,000 meters over 1 kilometer by 5 kilometers, the kilometers cancel out. So 5.00 kilometers, I'd multiply that by 1 kilometer is 1,000 meters. And of course, to help you keep it straight, sometimes it's important to go ahead and make that a fraction. Remember, you can always make a fraction by taking a number and putting it over 1. So by doing that, I now see that this is just like 5x times 1,000 over x, right? So when you see that, you can say, oh, well, this kilometer is going to cancel out there. I've gotten rid of the unit that I wanted to get rid of, and I'm left with the unit that I wanted. And all I have to do now is multiply the numerator times the numerator to get 5,000, and then the denominator times the denominator to get 1, and then the unit's what remains. So ultimately, I'll just say that's 5,000 meters. So that's the method that we will actually use when we're trying to convert units. I'm going to go in more detail. I'm going to handle units like miles per hour, meters per second, meters per second squared, kilograms per cubic meter, grams per cubic centimeter, grams per liter, all that kind of stuff. That's what we'll do next time. But we've gotten a pretty good distance away. I would have liked to cover more. And if I don't get to cover all of it face to face on this Zoom meeting, that's part of the reason that I give you the video, because some chapters are easy enough where you can sort of figure it out. You do need to know scientific notation. So you need to be able to convert back and forth between scientific notation and standard notation. Hopefully you all know that. If you've ever had a chemistry or a physics course before, you probably already know that, probably even if you had an astronomy course. So you definitely need to know that. You need to be able to convert between units. That's what I'm showing you now, and I'm going to show you a lot more of that. And we're going to cover something called dimensional analysis, where we can literally use the fact that if something is equal to something else, they not only have to equal each other in numerical values, but they also have to equal each other in dimensional or unit values. So that can sometimes be used to make us, to allow us to make hypotheses about equations. And sometimes those hypotheses are exactly correct. Okay. All right. Our time is up. It's now 6:40. You guys are free to go. I'm going to wait here until the last person leaves in case any of you have questions. And remember, I'm going to send you emails as I post stuff, but you guys are free to go.
Thank you. Have a nice night.
Have a good
You
one.
too. Thank you.
It's funny, I'm barely hearing
Can you hear me? Can you hear me? Professor Younger.
Try talking now, Hannah, see if I can hear you.
Can you hear me now?
Yeah, I can.
Okay. I'm in a little bit of a predicament. I'm dual enrolling in this class.
You from
with
Eastern
also at my
Shore?
home. Yes.
Oh, you are at high school.
I'm from Virginia Wesleyan University.
Oh, okay, gotcha.
I have my classes starting, like my spring semester starting in the end of February or the end of January. I have a night class that interferes with the lab that is attached to this course. I wasn't sure if you would be okay with me coming to your Monday morning lab.
Yeah, that shouldn't be a problem.
Okay.
I would just have to let your lab instructor know. We can do it off the books, so you don't actually physically have to do a change of grade, because the way this course is set up, it's supposed to be each student in this section of lecture has this section of lab, but rather than having to change all that, we'll just let you do it, and I'll constantly give your grades to Ms. Raskovich.
Okay. I have spoke with her. I tried to email with my email. I was never able to reach you, and I got advice just to join your class and then ask you now.
Yeah, I had surgery over the break, so I didn't answer hardly any
Okay.
emails once classes was out. But yeah, and I'm also not that good at answering emails before the semester starts
No,
anyways.
totally understand.
But yeah, that's certainly not a problem. I can work it out for you. Just remember when you come to my lab, you might want to just remind me that you're there from another class, and that's fine.
Okay.
We do meet at 9 a.m. on Mondays. And actually, for this week, we already had one lab. I actually have the videos going up right now for that lab, so you can still sort of attend virtually and see what you got to do. And that'll make up for the first lab, unless you did lab already with Miss Raskovic.
I have not. I plan to just go to her Thursday. I don't know if you know what a J term is this
Mhm.
January, and which sucks because it's why I'm in such a sucky position. That class is Monday through Friday, 8 a.m. to 12. So I would miss, but it's only for the next 2 weeks. So I plan
Gotcha.
to go to her lab this week, well, just in case you said no. And then